Thank you, Scott. So this presentation is BIM Consulting, Lessons Learned for Owners. My name is Edwin Guerra. I am a BIM consultant with Summit BIM here in Vancouver, have been for the past 8.5 years. And this presentation is trying to summarize some of those lessons which we have learned through many years of working with owners in healthcare, in airports, education, and even some power plant type projects. So the outline of what I will be covering is, first I'm going to give you an overview of the owner and what their perspective is. Then I'm going to give you a brief overview of what BIM Consulting offers as a type of service to meet some of those needs. And then we're just going to jump straight into lessons, which include challenges, solutions that we found, and what we see as the next frontier, or the future problems that still need a lot of work and are difficult, and that we should be spending more time talking about. So the owner perspective is very varied, but there are many things that we hear from owners. Some of the ones that are shown up here on the screen, highlighted in red, echo some of the presentations that you may have heard earlier this morning. As-built do not reflect the building that they received. They have very limited time to review the design. They only see it at 2 to 3 snapshots in time during design, and they're expected to catch everything that is out of compliance. They need to project maintenance costs for these new buildings that are coming online for budgetary purposes, and they're doing it manually oftentimes, looking at paper, counting things, which is error-prone. So another thing that can happen is that they'll receive at the end of the project, again, when things are just like BIM will be a deliverable, they'll receive 5 models, Revit models, let's say, and they don't know what to do with them. Or this last one, I think, is key about the current state of the industry, which is that from the owner perspective, there appears to be no difference between a BIM and a non-BIM project. When it's not managed, the building's still delayed and over budget. So we're exceeding 2 decades of building information modeling and management, and we have to ask these hard questions of why aren't we getting those benefits? Is it all smoke and mirrors? And it is a challenge when we come to conferences like these that oftentimes we celebrate our successes and push some of the failures under the rug. So if I can elaborate further on what an owner may be looking for, there's also the arm of the facilities maintenance people who basically need to maintain assets. So not everything that gets modeled is an asset. We like to call this tracked assets. But basically what it comes down to is that people need to know what something is and where it is. So that means that the where it is it's a building, it's in a certain level, it's in a room or a space, and then we have an asset with different number of properties. And the reason this is important, again, is that when someone gains ownership at handover of a building, they need to maintain it, and having a handle on the maintenance schedule that needs to be followed for warranty purposes or just basically for maintaining the operation of a building is quite important. And as I was hinting earlier too, there is that feeling in the industry that the owner needs the nuts and bolts, which is this image on the left. When we speak to owners and operators, they're not as concerned for the nuts and bolts. The design model, with its level of development, is more than sufficient. What they are interested is what do I need to maintain? Again, how often do I have to do it? How do I do it? And how do I do it in a way that doesn't violate any warranties that may already be in effect? So not everything is tracked assets. Again, if you look at the bulk of a model, once you have all the models together, most of the elements are pipes, pipe fittings, ducts and duct fittings, outlets, data outlets. That's not what we're talking about. What we're talking about is the major equipment that does need servicing regularly, and that will be a major expense once it fails, because most of these assets, again, are on average lasting 15 years. So throughout the life of a building, they need to be maintained and replaced eventually. And there's a cost associated that can be quite significant that needs to be planned from an owner perspective. The other side of the owners and what they get during handover, whether it's facilities maintenance or capital planning, is again this paper legacy of drawings that are taking up quite a bit of room, usually in the dark corner of a building, and binders too, which usually have that information about how something should be maintained. They're handed to the owner many months after occupancy, which should be unacceptable in this day and age. So what we're moving towards and proposing is that there's benefits to having the information digital. When it's digital, we can search it, we can query it, we can reuse it, we can store it securely, back it up. It's basically how every other area of our lives is moving towards, and construction and building should be the same. So that's giving you the overview of the owner perspective. When we talk about BIM consulting, there's many different services that are provided, many which start from the pre-design of a life of a project. So you can think of, as it was hinted earlier, if you were sitting at the previous presentation in this room, that you can't just jump into a project and do building information management. What you have to do is you have to plan. So the first stage, again, before you even have a project, usually the catalyst for this is that you have one or more new projects coming along, is that you have to plan and take a look at how you do things with the purpose of generating rules of engagement so that you can have predictable behavior, so that everyone who's going to be a project participant has an understanding of where you're going and how you're going to do things in the most effective way. Part of this is also developing what we like to refer as KPIs, key performance indicators, to assess during a project's life that we're actually on track. So you can think about checking things during design and construction, seeing evidence of virtual coordination, managing or having more transparency with regards to change orders and RFIs and site instructions. And substantial completion date, right? It's a good indicator because it is a good target, and we know if we're ahead of schedule or not. So that is the pre-design stage of BIM consulting, is that we spend time with stakeholders from the building owner group, again, trying to educate and bring up the level of understanding of what building information modeling can potentially offer to make their lives more simple, and creating these agreements and rules of engagement so that there is clarity from the RFP stage that is more significant than a one-liner about BIM. So the outcome of that is normally, standards that specify in detail what those objectives are and what that translates to from a modeling perspective for design and from a workflow perspective for design and construction. And it is key to understand that it is a whole life cycle that we're looking at. It's not just design and it's not just construction. We need to basically consider the end at the beginning and use all that information to have alignment. So during design, then we still have those rules, right, which are the execution plan, the rules or guidelines, however you want to call them. But we add a level of enforcement, right? So during a project, we want to make sure that things are actually being addressed. So we like to think of ourselves like a SWAT team that just jumps in. The reality is that we're more like the annoying teacher yelling at a student who is oblivious in their phone. And the reality is probably more in between. It's more like a DUI. Like, we know that you're doing something wrong, and there's a record of it now. So the role of BIM consulting during design is that of quality assurance, quality control. you cannot just rely on having standards and having rules that you hand at the RFP stage, again, the contract language, because the reality we'll see later is that that is very weak. And we've had many clients who have engaged us over the years to develop standards with the hope that they can just give them to their design consultants and contractors, and everything will work out by itself. And unfortunately, those clients usually come back for this in the compliance stage during a project so that they actually get the benefits. Because if no one's checking, the reality is that things won't get addressed. So some of the deliverables at this stage are things like reports that tell you basically, are you on track with what the requirements are for this specific project, and what are the implications if we don't do anything. During design too, part of what we do, which has been hinted at earlier, that is very important, is that we need to share information. Most of the project participants are not in Revit, have no interest to live their life in that authoring software. But they need to have access to the information to review it, to know that it's correct. And the way of doing that, from our perspective, is to grab those models and extract them into a true external database that makes sense of everything together, so that we can then collect information, things like shop drawings, warranty certificates, serial numbers, installation dates, for those tracked assets during construction. But during design, it can also help so that people, again, the owner specifically, can be more engaged and more knowledgeable about what is being generated. And the purpose of this is so that at the end, in that right-hand side, you have what we call a consolidated digital building, which is not just the design models, but it's the design models augmented with the information of what actually got installed, that can then move on to other systems that are usually legacy systems within an organization for tracking things like assets, space planning, and any other number of things such as capital planning, financial projections, if needed. So obviously, the best engagement is to have everything from before design to actual projects. But we have, and BIM consulting can bring value just during design and construction if needed, for that same purposes, to expose the data to a larger audience to review it, during construction to collect data and push it onto handover for facilities maintenance if needed. And we have done previous engagements with just contractors who just needed to deliver basically that last step of collecting the installed information. We have methods of using that, of doing that using the model, so that handover, again, it's not manual entry that takes months and ages. It's during construction, as the data gets uploaded, as things happen, you know what is going in, you see the shop drawings, and it's all done. So that brings us now to the idea of the lessons. And one of the key lessons that we learned very early on is that standardization allows for higher order magnitude benefits. So very much like the shipping container made basically the shipping through the ocean of goods and service of goods very efficient in an industry that was very inefficient, very slow, very wasn't safe. That is the type of efficiencies that are brought when we bring in standardization. And some of the things that you can do and look at are things like OmniClass, which is an international standard for organizing many different things. So here below you can see listed some of the tables that have been developed. Not all of them are developed to the same stage. Some of them are still more in draft form, but some of the key ones are, and the ones that we have implemented and try to push the industry towards, are things like OmniClass Table 23 for products, so that those tracked assets basically can have a standardized naming, because the reality is that the owner is receiving information at the end that they need to have in a wider context of their building portfolio. So to them, a project is not just that building, it's many other buildings that they already have. So to have an understanding of that, they need a common language so that if Stantec calls it an air handling unit and someone else calls it an AHU, we know that we're talking about the same thing. And again, we don't want to mandate that the design team adopts a standard naming convention. We try and give them as much freedom as possible so that we can get something valuable at the end. So this is now trying to show you that these tables fit in within different areas of what you're standardizing. The national CAD standard, for example, is a good starting point for just sheet numbering to make sure that it's standardized, whether you're looking at an electrical plan or a landscape plan. They're in the 100s and not in the 200s and so on. Similarly, if you're classifying assets by system, you're looking at different tables like table 21 in OmniClass. So these are the things that are going to allow us to then future-proof the data so that it can be reused. And some organizations will have internal standards that they've already developed. So things that are important for building information modeling are things like level naming conventions, room naming and numbering standards that include things like shafts and stairs and potentially roofs and exterior spaces, because there are assets, obviously, that are not just inside the building, and naming conventions that you may already have. Another lesson that we learned very early on is that as we move into from design into construction, the owner is looking at black and white paper, which is its purpose is basically to build the building, to then do a review of whether it's correct or not. So part of what we've done is we use the data that's held within the model to generate rules that will color code and make sense of the information for different purposes. So an owner-operator needs to, for example, doesn't need to see all that clutter. If they just want to know sort of what is the supply, what is the exhaust, what is the return, we should make it easy for them to see that information. And because we have a model, it's also very easy to generate 3D views, isometrics. And again, this is not a manual process. This is just relying on the standardization that we've applied to say, okay, this is what you name a system when it's an exhaust air, and this is what you name a system when it's a supplier. During design, it's also very important. This was a healthcare client. They're looking at black and white to do their review, but if we can color code the information that's held within a room, it's very easy to then see where things are in alignment or out of alignment. So if you need to look at STC rating for your rooms, make sure that it's met. Again, that's an owner project requirement that's outlined very early. And we tell the design team to basically have a parameter that holds that information in a standardized format. Then we're able to color code and make the review process more efficient, faster, and more reliable. And this is, again, still partially manual because someone has to review it. But we can also create automatic rules using tools like Solibri Model Checker to basically just click a button and see where we are out of compliance. Another early lesson that we had was that level of development, LOD, seemed to be all over the industry. People were talking about it, saying like, oh yeah, my model's 300. And the reality is that we saw a lot of confusion because we found these models that they say, okay, it's 300, and then we look at an outlet and there's no 3D geometry. And that is the case for most electrical projects, actually, if you ever look at one model. So it is very confusing, the way that it's been implemented by BIM Forum. We decided to deviate from it and just basically split it out in a way that made sense for us into data and geometry. Because to us, it's not like the data and the geometry are both getting more refined during a project. We can have a 2D representation of a chair, which is an element that, for example, doesn't need to be coordinated. But what we want to have information on is what was installed, right? Who is the manufacturer? Is there a shop drawing for it? That is the information that is of value. So you have to be strategic, basically, in the modeling strategy. Similarly, design teams like to download families from the internet. So here, for example, is an air-cooled chiller that was downloaded from a website. And the geometry is beautiful. It's very detailed. It even has the logo. But when you look at the information, the things that do matter, like the family name and the type name and the Omni class, none of that is in there. The Omni class is using the old format from 2006 rather than 2012. And if you were just to look at the family name and type name, you'd have a very hard time identifying what this object is. So that's where design teams need to have more consistency in how descriptively they name their families. Similarly, there are other disciplines that do not participate in Revit specifically, but are generating potentially models or drawings. So that's like landscape. So this example here is showing how there are trench drains in one, but in the other one, there are not. And this is basically IFC stage drawings, right? So how can we communicate and have processes in place that manage this information better so that the changes get tracked? Because if there's a trench drain, there's going to need to be piping, and if there needs to be piping, that needs to be coordinated. And if there's discrepancies within one and the other, again, it matters, not just for coordination, but also for the record model. Another lesson is that tracked assets need to be modeled. There are many shortcuts that people take, design teams take. They can use lines and text, and things can look beautiful on the drawings, but when you actually look at the model, they're not there, right? So here, there's an example of these variable frequency drives, VFDs, that were caught early on the left side, that they weren't modeled, the host bit wasn't modeled. And then when they eventually got modeled, you can see on the right side, there wasn't enough room because there were already electrical panels. So then they just stuck them on the bottom horizontally, which is actually not how VFDs are installed. They're installed vertically. To highlight again that this needs to happen, and it needs to happen very early, because if you don't model things, these will lead to issues. And this is why we're not getting the benefits at the end for a project. Equipment clearances is another thing that needs to be very early on in a project, because if you don't allow the space for something, it's very rare that you're going to get it. A good rule of thumb is basically 3 feet in front of anything that needs to be serviced, because again, if you remember, 15 years, it has to be replaced several times within a lifespan of a building. You're going to need room to wiggle there and move, bring tools. In this case, again, the clearances were not modeled. It's not too bad, right? It's if you can read the little blue dimension, I think it's 800 and some millimeters. So it's getting there to the 900 millimeter range. But best practice, again, would be to include that, so that, again, you're not just building something that can be built, but you're building something that can be maintained easily without having to shut down other things and remove equipment, which can be very costly. Other lessons that we've learned over the years are that duplication will inevitably bring discrepancies. So here on the right side, there's a grease interceptor. The green one is what the placeholder element is for the architect. The blue one is what's in the mechanical model. There is no reason why this should be there once you get to a late stage of design, right? The best practice would be to remove the duplicate, the placeholder item, and just leave what the mechanical person has placed there. The reason for this is not just for coordination or clarity of design, but also because at the end of the day, again, we're going to be collecting documents against each asset. So we need to make sure that there's clarity in which asset holds the information. And if we have 2 assets, you don't want to have extra clicks for no purpose. Similarly, on the left, architecture and structure are always are very often duplicating stairs or floors, and oftentimes they don't match. So this, again, highlights the need for, okay, if we're going to generate a record model that's going to be accurate at the end for the benefit of the owner, why are we duplicating also our work? And this other one is, again, in purple, the architecture interpretation, and then in cyan or bluish color, the structural interpretation. You can see that they don't match. And these are pervasive issues in our industry that we don't talk about very often, right? So it looks great on plan, but we're generating a model for virtual coordination, but if we're going to do virtual coordination on things that are not accurate or are conflicting, then our benefits are going to be diminished. Similarly here, again, in magenta is the architect's interpretation, and in cyan is the structural. Major differences. This was early in design, it got rectified, it's not a big deal, but you can see that these types of things can be pervasive and could, if someone wasn't checking to make sure that they actually matched, it's very easy that the drawings look fine, it gets built either way, hopefully the way that it was intended, but it represents a risk because then things may not work out, the details may not actually work. Another lesson that we learned is that virtual coordination can happen very effectively without doing any automation, right? If you just color code things. Because if you just have the colors that are out of the box, it's very easy to get lost and not see what's going on. But once we bring in color and the systems, then it helps us verify that the design actually works. There's also the idea of it's not all clash detection, right? It's all about having a process where you have a clash hierarchy, that you know that gravity systems are harder to move, and then that should be something that gets discussed and documented in your project execution plan earlier on. This lesson is having to do with how, even though we are using Revit oftentimes or other authoring tools, that doesn't mean that everyone is putting the models together and looking at them. So you have to make sure that that the models are being geolocated correctly so they can be brought together, and that someone is reviewing the information that gets generated. Here on the left-hand side, this was partially existing piping that needs to be removed. Some had to be put in. Early on in design, again, it looks great on paper, it looks doable, but it's tight. And if you don't model correctly, and if you don't have a strategy for dealing with existing conditions, it can really hurt your process. Similarly, here on the right, this would be mechanical and HVAC type systems that are clashing. It's not uncommon to find within the same model that things are not clash-free. So you need to have something in place that will ensure that people are modeling. Next lesson has to do with modeling accurately, right? So we talked about LOD, right? And people love to throw that around. And this is the reality of it, is that on the right side, that's what we saw very early on, is ceiling speakers on the floor, fire alarms on the floor. Looks great on plan. But there's lighting above, there's other things, grills and registers. If you are not coordinating properly, or if you run your clash, you could say, oh, I have 0 clashes, right? But does that mean that you have 0 design issues? No. And some of these things now are included on the left-hand side. That's basically at IOC stage. You can see that one of those control panels is still at the floor. So some of these things, again, are very hard to fix. They shouldn't be, right? We're in a digital environment. If we're modeling accurately, we should take the time to do it properly. So with that alone, these 3 things that we've just discussed, duplication, why it happens could be its own topic, assets not modeled or assets modeled incorrectly, geometrically, in orientation, size. These alone should make you wonder, why am I doing virtual coordination if I don't have a good handle on this differential between what the drawings are showing and what the model is saying? And as hinted earlier too, some issues are just not clashes, right? And you need to have a process of capturing those. So if you have a gutter right in the middle of your window, or if your bathroom is not usable or not private because the swing gets in the way, these are just as important as the things that are hard clashes. And you need to have a process in place to make sure that you capture them all. And then since most of the things that matter for the owner, again, are maintainable assets, which are mostly mechanical and electrical, this is kind of the dirty secret in the industry, is that most, if not all, schematics that are shown on drawings are generated and are disconnected from the model. They're manually generated to align with what the design is saying. So this is a huge risk. And this is, again, where people like Autodesk should listen, because we are going to lose a lot of value if these things are manually generated. They're error prone. So there could be valves and assets that are shown in a schematic that are not reflected in the model. And this is a huge risk as we move into commissioning, into collecting data, and having an accurate record model of what got installed. So digital twins, this is where we're at. Digital twins, again, is a term that is very overused these days, but the reality is that what we're showing digitally is very rarely reflecting to a high degree what is shown by the drawings or what is the design intent. So coming back to the lessons, a consolidated model makes sense, especially for mechanical and electrical. If you know some of the limitations in Revit, is that if you're creating electrical systems, they only understand the logic within their own model. And normally we employ a mechanical and an electrical designer, and they're working in their own model. So where possible, we found that there is quite an efficiency when those two disciplines can work together, because then the systems can be connected, the information can flow, there doesn't have to be any duplication or workarounds. And the end result is that it's a model that's easier to maintain after handover, because the building owner, if they do want to update the model, they don't have to go to two different models. They can do it in one. Another big challenge and lesson that we've learned is that there has to be a risk analysis done of what information is used originally to generate future projects, right? So if you're in an existing project, existing facility, and you're doing renovations, people like to use as-builts, but what we find is what everyone else has found is that as-builts rarely, if ever, reflect the true build condition. And part of it is contractual. If you look at your contracts, it's usually just one line that says the contractor has to do red lines, and then the consultants have to deliver as-builts. So having a more controlled process is necessary to ensure that what you get at the end is something that's reflecting what actually got built and installed. And when you are starting off with as-built information, it's important to assess what information is known, or which one needs to be verified, and which one might affect your specific project. So redlining, as I hinted, is part of that record model generation process. And it's really up to the contractor, right? If they remember and capture it, then there is hope that eventually it might get reflected in the as-built drawings, or record drawings, and record model. But if it's manual, and we need to check it, right? So one way that we found of doing this is, again, to be kept in the loop of all the RFI, site instructions, any changes that happen on a project, so we can better evaluate if those will result in a change in the model, and then having a process so that the record model gets updated during construction and not after everything is done, so it is more manageable, and so that we can check also that those changes are being reflected in the model where they count. Another lesson is that construction photography brings value. If you think about Revit and most modeling authoring tools in the market that are used, there's simply not enough level of development that will capture what got installed, right? So the final wires, the very small piping, the studs even don't get modeled. And it is of great value for an owner to have access to this information. If they have access to it, then they don't have to basically expose a building. So prior to concealment, whether it's underground services or anything behind the wall where there are services, you can take a picture. These days, it's actually very simple. Using an iPad, you can start, or your phone, whether it's Android or iPhone, you can enable GPS locations, which then allow you to at least have a record of where those pictures were taken, in what direction they were taken, the date and time. And this can be a valuable record that can be used for facilities and for maintenance of buildings. That is very low cost and brings a lot of value. Similarly, we identified very early on that there's many opportunities, one of the biggest ones being collecting information during construction. And having a way of doing it that is easy for a trade to just basically log into a system and know what is required of them and be able to provide information, whether it's a shop drawing or a serial number. So we have developed an in-house tool that is both a cloud application and then also a desktop application to manage this process. Basically collecting the information and assigning it to each trade and having tools to basically have the trade know how much more data they need to collect. So that's the progress report that's shown here. In green is what they have already supplied. In red is what they haven't. In gray is what has been assigned to potentially a different trade or is not required for them for that specific asset. And the value, again, is that we're trying to create a consolidated set that is not just the model, but it's basically at the end something that an owner can click on and see what got installed, who uploaded that information, and even the history if they uploaded a shop drawing and then that drawing got, or shop drawing got superseded by another one. And part of this is that it's very important to have clarity, right? If we're expecting that there's not going to be a change in how much a project will cost, is that we need to have clarity from all participants, both design and construction, of what is expected of them. And the latest iteration of that is what we call a data and geometry specification that tries to capture, again, what assets are in the model, what assets are tracked by an individual building owner, at what point in design and are we expecting to see that information, what information or parameters will be provided by the design team and which ones will be provided by the contractor or trade afterwards. So again, the idea is that the design team creates basically a container object that then can be augmented with installed information. And that way we're keeping the audit trail very clear because we don't want any confusion about who is providing or generating the information. The design information remains design information. We just augment it with installed construction information. When we're collecting PDFs, it's also important to know that not all PDFs are created equal, that some are generated from an authoring application, which means that they're searchable, that we can select text and copy it if needed. And the other one is basically just like an image that we scan, which is not searchable, and oftentimes is like this one, which is a real case, and the bottom, which is hard to read, it's a little bit degraded. So you need to have that level of specification and clarity from the trades to know that they're not going to be just handing you over something that they scan manually, but something that they download the spec sheet from the manufacturer and then they annotate using any of the number of tools that are out there so that it's all digital. And then we get to the next frontier, which is that we have found that issuing reports and sort of these status updates of whether we're in compliance or not when you're in a project deadline, is very easy to ignore, right? So what we try and do now is to schedule meetings along with those reports. They still serve a purpose of being a record of what happened, so that we can discuss and have clarity, because oftentimes we feel like we're experts and we're being very clear. And oftentimes we find that the design teams or consultants or contractor are understanding something completely different. They're saying like, oh, we need to model fabrication models with every hanger. And it might make sense for certain projects, but it doesn't need to be. So having a face-to-face meeting makes it harder for people to fall asleep, and makes it easier to communicate and have clarity, even if it's felt as an expense to have to physically be in the same room. It is something that we found can be quite valuable. Having champions is another very important thing. Our goal is always to be 2 levels deep within an organization and wide, because people in our industry do move, and it can be very damaging if you have all this work done and a person leaves that organization and then there's no one that sees the value or is willing to push for it. So project teams change, and being prepared is part of having a documented process and having clarity, not just externally from the building owner to the consultants and contractor, but within the owner team, so that there is a succession plan. People retire, people move. We need to make sure that these things are kept on track, because they often span many, many years. Another next frontier is that, again, we have to update those standards, and that can be challenging when we have multiple projects, knowing which standard is current for each one and which one covers the objectives in the most elegant way. So making sure also that they're aligned with the current contract language, right? Because oftentimes they just kind of get added on to whatever is issued at the RFP stage. There is a step where we have to make sure that if they're talking about as-built drawings and we're talking about record models, there's clarity about what we want. And if they're still being asked to deliver binders at the end of a project, and we're saying that it's all going to be done digitally, it's going to create confusion and additional costs potentially from the perspective of a designer or contractor. Similarly, it has to be stated that most designers will agree to almost anything in hopes that no one checks. So the compliance step is something that, again, needs to happen. If it's not an external BIM consultant, it can be an internal person, but it has to be someone knowledgeable with the standards and the guidelines that you're proposing, and checking for that compliance periodically in a way that within the project schedule makes it possible for people to fix their mistakes or to realign with the overall objectives of a project. Another thing that we are starting to see a lot of value is that it pays off a lot if you can have a trade or contractor be involved early during design, because they see things in a very different way. They have a lot of experience. They know what is easy to do, accomplish, and what is hard. And designers simply don't have that knowledge base, right? They're not on site doing these things. So they don't understand the nuances and complications of scheduling, of the fact that you have to support the pipes, right? Either from the floor or from the ceiling. Those things can matter quite a bit once you get into construction. So having trades involved early on is money that is very well spent, because it can prevent a whole series of rework once you move from design to construction and find that, well, these things weren't accounted for. Similarly, we need to do more of this, sharing not just the successes but failures, and having process in place to capture these lessons learned in a formalized manner, so that we don't start a new project and just start the learning process all over again. The benefit of doing this is that it's a big data concept of learning from what we track and and doing things the most efficient way. So it's not just about tracking, it's not just about having RFIs in a spreadsheet, it's about seeing those business insights, mapping them out to see, okay, where are the issues normally, and how can we mitigate or try to prevent them in future. The human element was discussed earlier this morning in this room, and change management is definitely the next frontier, because people are very used and comfortable in how they do things, and doing anything in a different way is disruptive. No, in your lives, you can think about anything that you are asked to change. It's a little bit more effort. We're the creatures of habit, and it's hard to change those habits, even if there is an order of magnitude in efficiency gains. That has to be communicated, but in the end, people have to feel comfortable with these changes and feel like we are all aligned in one direction. Because when that happens, then people are more open and things can happen with less effort. The other reality is that we shoot for the moon, but we don't always get there. So we have to keep in mind that the standards have to be aspirational. We're not expecting 100% in the first few projects, but we want to have 90%, right? We want the 90% so that we can demonstrate that this is a better way of working. And change has to be fun. So if you have seen videos like this where they transform the stairs into a piano, and then people start using them more than the escalators, that's kind of what we're getting at, hacking the mind and making people do the right thing, or what we believe is going to be valuable for the project in a way that is fun, and because it makes sense, right? But it has to be fun for people. It doesn't have to be an added chore, and that's challenging. And also, one important thought that I want to leave you with is that low-tech can be high-tech. So this is an old study that was done back in 2011. And it was basically following different BIM projects during construction, specifically their coordinations meetings. One set of projects basically had the big screens with the model and a whiteboard, and the other one only had the big screens. The one with the big screens found more issues, right? So it was a small sample size. But the idea of the researchers, or the findings, were that the fact there was a whiteboard allowed the trades to be able to participate in a way that they couldn't when it was just the model that was shown up on the screen. So this is, again, to illustrate that low-tech can be high-tech. No, the end goal is to have a coordinated design that results in a building that was efficiently done in a way that we can do more of them faster and better and make money through the process. So it's not all about technology. A lot of it is just about making sure that people are able to express their expertise and share it within a project. That is my presentation, and thank you.
Good, great presentation. Just wanted to comment the LOD, what you were stressing, because I think it's so important, because oftentimes we apply LOD to the model as a whole. And I think more so the intent has to be applying it to the components. And when we do that, then it resonates better with owners and facility managers to know what items are of a certain level and what items are not. And for you, I think the delineation between geometry and data is spot on, because that's similar to how the UK does LOD, LOI. And you can have a higher development with information without necessarily augmenting geometry itself. So just spot on, just wanted to comment.
Yeah, thank you, yeah. Basically, yeah, the owners care more about the information. They don't care as much about how things look on the drawings. So that's a shift that happens from design to construction and handover, is that slowly from design, people care a lot about how things look on paper. Once you get to the owner side, they just care about having the information, like what got installed. I need to have confidence in that. So yeah, we see multiple international bodies that are moving toward in that direction, and we found that afterwards, and we were very encouraged by it.
You mentioned a little earlier about organizational hierarchies, kind of, whereas the owners are concerned about location, room, area, and specific asset, as opposed to construction, which might be completely work breakdown focus. Owners may also be concerned about like functional hierarchies, CCTV system, camera network, camera number, whatever. Do you have any insights or comments about these, I guess, competing hierarchies, or how they can be managed or dealt with?
Yeah. Yeah, so the key, I think, is to have a definition, yeah, of what you want. Like we said, for a CMMS perspective of operating a building, it doesn't matter which tool you're using. It seems like it's organized the same way, right? Level, room, asset, and then properties for that asset. When you look at other requirements from the contractors, again, they still need to organize, right? So OmniClass, for example, serves both purposes, because OmniClass allows them to start sectioning off key elements that are of importance to them. And it's more of an art than a science, but that's where I think standardization plays a pivotal role. To us, it doesn't matter if you're using Uniformat or Uniclass. There's obvious differences between them, or master format or uniformat. But the importance is to have a common language that allows that information to be sliced and diced in whichever way makes sense. And part of it is that idea of having it in an external database, because then we have additional information that can be used. But it definitely is a challenge. So I don't see them necessarily as competing. I think that if there's a good plan in place, we can basically have a lot of those win-win-win scenarios where everyone gets at least most of what they want, and the project is improved. Thank you very much.
Questions? Right.